right, well, good morning, everybody, and I'm super pleased to be here at AWE. Thank you for inviting me to talk about these critical building blocks of AR, particularly as applied to enterprises. So if we start at the beginning of the story, if you own an enterprise or manage an enterprise or even work in an enterprise, you know that there's three basic ways to get work done. You have sort of physical, digital, and human levers you can pull, if you will. And these levers each have their own advantages. Machines have a tremendous ability to do hard work and do it for a long period of time in a difficult environment. People, on the other hand, are much more creative and respond much better to sort of unforeseen circumstances. They can communicate and sense things that are very difficult for machines to sense. And then, of course, the cloud or the digital world has tremendous computing power, tremendous data storage and memory, and this incredible capability to do artificial reasoning and intelligence. And so I've been in business for about 30 years, and the connection we forged between digital and machine has advanced dramatically in that time frame. In fact, I remember I'm an engineer, and when I started in business, the way you program a machine is with a 1-inch paper tape with little holes punched in it, and each row of holes was a byte. And so I think in 30 years, we've gone from paper tape doing a byte at a time to real-time control, to artificial intelligence, to 5G, to all these amazing things that have elevated the power, if you will, of machines by bringing the power of digital to the power or to the machine. Humans, meanwhile, I'd argue haven't progressed that much because when I started 3 decades ago in my first professional job, I was given one of those Integral Macintoshes. And it had a little screen where digital information, bits and bytes, could be represented as text and icons. And so that's how I got my digital information 30 years ago. And today, from the same company, I have the new screen, the iPhone 10, and it's just a smaller screen. The pixels and the colors are better. It's mobile and wireless and connected, but it's fundamentally the same way of communicating information to me through icons and text. And, okay, we've added movies and stuff, but my point is the human side of this equation hasn't benefited the same way. But I think that AR is the answer to how we connect people to the internet. So if we can make smart connected machines, smart connected products, I think we can make smart connected people too. In fact, I argue when you put on a HoloLens, you basically put a modem and an edge device on your head. And this would be true of any AR device. But you're basically using a device that turns you into a cyborg, part organic, part cyber. And now bits and bytes streaming down from the cloud get converted to analog signals, to sound, to sights that you see and hear with your analog senses. And meanwhile, when you speak with your voice or move your hands around, the analog signals you're creating get converted back to bits and bytes and sent up to the cloud. So I would argue that a HoloLens really is, as I said, a modem and an edge device, and AR is IoT for people. Now this is kind of interesting because if you could bring the power of digital to people like we have to machines, then some real possibilities could come from that. In fact, I want to show you a sample of our customers, a survey. We publish this, by the way, periodically because we update it. So 134 of our customers were involved in the last survey, and we asked them, what are you doing with AR? And the takeaway, once again, is everything. I mean, they're using it in every part of their company, in sales and marketing, in product development, in manufacturing. They're using it in service. It's out at the customer site. It's used for training by the corporation. I mean, it's incredible. In fact, if you add these numbers together, you get less than 50% because there's a very long tail of use cases for AR and to a degree VR being deployed in enterprises. So what I want to do is step through a few of these use cases and then come back and reflect on them. So the first one is a sales and marketing use case, and you've seen an example like this already this morning. But imagine this applied to highly configurable machines or capital equipment, things that you can't have in a showroom because they're too configurable and they're too expensive to let sitting around. But AR is a great way to virtualize them and to confirm with the customer that this is what you want. So this is an example of a sales and marketing use case. That was IKEA. Here's an example of manufacturing work instructions. This comes from a company called BAE Systems. This particular part of BAE is assembling hybrid bus batteries. So this woman here you're going to see is going to see assembly instructions floating in air in front of her. and she's basically just following those instructions step by step, confirming each one, and being taken out of the next one. She'll assemble this bus battery very quickly, won't make any mistakes, and then we'll actually confirm that she did every step of it along the way. Let's take another look at a use case around knowledge transfer. So every company has a problem with retiring workforce. You know, Joe, who's worked here for 40-some years, is going to retire, and he's going to take that 40-some years of domain expertise out the door with him. And we're going to hire somebody new to do what Joe did, but it'll take them years and years to become as good as Joe was. Is there some way that we could extract from Joe all that expertise? So here's a guy, this is the guy who's going to retire. Doesn't look quite young enough, but play with me here. He's wearing a HoloLens, and he's doing his job. So we're capturing everything he's doing as he does his job. And he's annotating out loud, he's speaking as he does the work, but he's going through the motions of doing the work. He's also authoring AR right now. You'll see that in a second. So he's placing spatial anchors associated with different things, like grab the players that should be over here. He's taking a picture right now. We'll place a spatial anchor to know that that picture belongs over there in that particular spot in space. We go back to the first spatial anchor, I guess maybe it's the second one. And anyway, he records this whole process. So now Joe retires, and a month later, Alexa shows up. This really is Alexa, by the way. And so Alexa is the new hire, and she puts on the HoloLens and says, take me through a certain process, which happens to be the cobot failure reset process, as annotated and captured by Joe before he retired. And so now the words in the spatial navigation and so forth that Joe created, the pictures, the videos, the words, are being delivered back to Alexa, and she's basically being guided or coached through this process by the artifacts that Joe left behind when he retired. So this is a tremendous use case around knowledge transfer from one worker to another. And it's important because one of the things that's happening with AR is that we can rethink the training model from in advance and just in case to in the moment, just in time, just in the place, right? And so when Alexa completes the process here, I want to let this run to the end because I want to show you something else, which is that HoloLens is also a sensor pack. So you're going to see some statistics here that it took Alexa 18.66 seconds to do step 1, 22 to do step 2, 13, and 19 to do steps 3 and 4. That's IoT data. Very, very interesting, because now I can look at how does Alexa do that procedure compared to other workers, and maybe I need to tweak the procedure, or maybe some workers have a skill set that others don't have, and it causes them to work much more productively, or what have you. So that's interesting data. We're going to take through another one. This is a warehouse picking sort of use case. So this guy jumps on his forklift wearing some smart glasses. It says, do you want to do a pick request? He says yes. He's going to pick up this pallet here. It says, please confirm you want to do pick request 351. Yes, that's what I want to do. It says, okay, here's the bill of material that you're going to have to go get. You're going to go to position 1. You're going to get 2 headphones. Go to position 2, get some netbooks, what have you. So now we're guiding him on the floor, and we're saying right about here with this green arrow, and now this green box, if you want to call it that, that's where your headphones are. Grab those and scan that you picked them up, and we're in good shape. So that's sort of a supply chain logistics type of use case. Here's a customer self-service use case. So this is a company that makes medical diagnostics equipment, a company called Sysmex. And this piece of equipment is connected to the internet, so Sysmex knows there's a problem with it, but rather than dispatch a Sysmex technician, they're going to coach the blood technician through a process of cleaning it. So we need to remove this cover, then take this swab, put it in there, wiggle it around, and then reassemble this thing, and it should be operational again. By the way, we know if it's operational because we know whether or not the fault code cleared from 1,000 miles away. So this is a high value use case around customer self-service, where you say if we could make service simple enough, we could actually have customers do much of it, or at least do the first pass. Because if a customer can fix that, that machine's only down for 10, 15 minutes versus a day and a half before we could get a technician there to take a look at it. And think of the cost of sending a technician there versus coaching the customers through a quick cleaning process to get that machine operational again. So that's an interesting use case. Here's another one, remote support. So this young lady works in some obviously very complex control room here. She's not exactly certain what to do, so she places a call to this expert who's somewhere else. And then the two are doing a video call with AR built into it. So the AR has generated a 3D model of that background, and this guy is marking on the background. And you'll see that as she pans her phone around, the marks aren't on the screen, and it's not a photograph. They're actually on the background. So they pan in and pan out, and they can both mark on it, so they can go back and forth collaboratively. So here we're authoring too, but this is the simplest of all, because nothing done in advance. Anybody could talk to anybody in the moment, ad hoc, collaborate, and go solve a problem using the power of AR. Now, I would argue then that AR has connected people to the internet in much the same way that's happened to machines. You know, people don't have an Ethernet port, but now they have an AR device that serves the same task of converting digital to analog and back again. And so that's sort of put human-machine on a different footing again, and sort of rebalanced, if you will, the power of each. It's also changed the relationship between them. So the next use case I want to talk about is a next generation virtualized human-machine interface. So this comes from a customer, Howden, and here we're using the new HoloLens, the HoloLens 2. Flips up, flips down, by the way. Here we're authoring against the 3D model of the machine, and then we're going to save that. Here we're using AI to recognize that 3D machine, and now we're lighting it up with a virtualized human-machine interface, which is really the control system. So I can see what's going on with the motor, the blower, the air handler. Here's the control panel. Oh, there's a fault code. Notice they interacted with that with touch, and now I can say, I want to order the spare part. There's a new HoloLens. This is a Microsoft video, by the way. And then here we're showing when the parts show up, those two red bearings are going to go right there in that shaft inside that machine. So this is sort of a different use case of man having a new way of thinking about and interacting with machines. By the way, the reason Howden does that is to differentiate that equipment. It turns out that air blower technology isn't exactly modern technology. It hasn't changed a lot in a long time. So what Howden sees is a chance to differentiate their equipment by the digital experience that they're going to wrap around it, and that's a big, bold idea. Okay, so I showed you a series of use cases quickly, because I really wanted to get to this, which is a framework we've developed. And I'm going to take you through this, but let me say first, it's completely possible that any enterprise could do all of those use cases and more. So, you know, the first thing to say is there are a lot of use cases here. I mean, we've identified more than 100 of them that you'd find in a typical enterprise. And the second thing is, while they all use AR, and they have much in common, there are very important differences between them. And in fact, the differences are very big, such that each one of those would take a unique approach to applying AR to a business use case. And so at some point, I got frustrated in conversations with customers and employees and so forth, because we were having low-value conversations because nobody had a common starting point, that I said, we need to develop a framework for thinking about enterprise AR. So my colleagues worked with me, and this is what we came up with. And it basically is 3 categories of 5 questions each. So there's 15 questions that you have to think about, and each one of them is multiple choice. And you can pick more than one choice, by the way. But for each use case you go after, you kind of need to go through these 15 questions and have a strategy and then a plan for developing the content and a plan for delivering it. So let's go through it piece by piece, because it's a bit complicated. So the first question is, what reality are you talking about? Do you want augmented reality, where you're bringing digital data into the real world? Do you want virtual reality, where you're obliterating the real world? There are reasons to do that, training and distance and so forth. Or do you want what's called assisted reality, which really isn't augmented reality, but gets confused and used with real AR? And that's just where you're providing information conveniently available to some frontline worker who's out in the field. And so all 3 of these are completely valid and very good at different use cases. So the second thing would be, what type of device do you want? Do you want a monocular headset? Lots of comfort reasons, battery life reasons, unobstructed vision reasons, why monocular headsets are great. Safety reasons, by the way, they're safety compliant. Do you want phones and tablets? I mean, they're incredibly democratic. Everybody has one, which is important for a lot of use cases. Do you want a heads-up display, a head-mounted display? And then what are you going to do about operating systems? Because one of the things that enterprises care about is the longevity of a solution. If they're going to create a software stack, and more importantly, a content repository, they can't have to start over each time the hardware is leapfrogged. So I think most enterprises are of a mind of, a point of view or a mind that they need to separate what's happening on the hardware front from what's happening on the software front, because they expect and they hope the hardware leapfrogs and leapfrogs and leapfrogs, but each time they can bring their software stack and their content repository along with to some new piece of hardware. So those are all things you need to think about. And then some use cases, by the way, need to run on multiple kinds of platforms, and some need to run simultaneously, like collaboration scenarios. I might be on an Android device, you might be on an iPhone, or you might be on a Windows computer, and I'd still like to be able to do that with you. So that's a case where, not only do I need to run on all those devices, but at the same time. That's what I would call multi-platform or mixed platform, perhaps. So that's a series of questions so far. Now we get to capabilities. What do you want your AR experience to do? Do you want to just visualize information? This Bose example in the lower left is showing on a real car where all the Bose products are embedded. Do you want to provide instructional content? Do you want to do guidance or even something cooler yet, which is programming? My PTC colleague, Valentin Hune, is here at AWE, and I'm sure you'll hear from him about his reality editor and how far he's advanced that technology. It does drag and drop programming on the physical world. So think of it like Visual Basic on objects that have control systems. So rather than program on a flat screen and go back into the 3D world and see how your program works, no, you put your program on or in the 3D world and interact with it that way, and you can visually understand what your program's trying to do. And then what senses do you want to stimulate? I mean, obviously, we can do sight, sound. I would argue touch, too, now, because particularly with the new features in the HoloLens, and I'm sure they'll show up everywhere else, we can now touch and interact with holograms. We can pick up holographic parts. We can push holographic buttons, like you saw in one of those examples. I mean, it really does. It's not truly haptic, but I've tried it. I mean, you sure do think it's haptic. You walk up to the button, you push it, the button goes in, and you hear it click, and you say, okay, I got the visual and the audio confirmation that I expect from a button. I'm pretty sure I pushed it. But in fact, you didn't, because it was just a hologram. There's other interesting things happening. Some of our friends at MIT are working on, for example, smell augmentation. Now, I'm going to make up a crazy example just to make the point. But imagine if every time you walked into a danger zone, you smelled a skunk. I mean, that's what we do with natural gas and propane, is we put a chemical in there so that if the gas is leaking, and it turns out propane and natural gas don't have any smell, but we add a smell. So if you smell that kind of rotten egg smell, you say, oh my God, there's gas leaking. That's dangerous. It's good to know that. So that's an example of augmentation by smell. But we can do that with a digital signal that would release a scent from a device you might be wearing to give you a quick confirmation that, oh, that's a bad smell. I associate that smell with a dangerous place. I'm not going there. So lots of interesting things happening there. Okay, now we'll move on to the content preparation phase. And so the first question is, how will I understand the 3D-ness of the real world that I want to put content into? I need some way to understand the shape of that thing or the shape of that space so that I can bring information to bear upon it. And so I could say, well, I'm not going to have 3D. I'm just going to do assisted reality. But I could say, well, I'll look for a surface and place content on a surface. That's what many AR apps do. You might say, I'm going to look for some kind of a marker, and that'll become the 000 point of my coordinate system. I might use a shape, like in that Howden example, as the reference coordinate system. And I'm going to use the actual shape, the 3D shape of that machine, as the thing I'm going to look for and place content onto. I could also have a modeled spatial. For example, architects might have created a 3D model of this room. But if they haven't, I could capture such models. For example, the Matterport example on the lower right. Matterport has captured 1 million+ models of buildings for residential and commercial real estate purposes. And it turns out those models work pretty well for AR and for VR as well. So lots of different ways to get a 3D model, but I would argue we need a 3D model. Second thing is, how are we going to create the experience that the end user is going to see? So I would suggest that most enterprise AR experiences start at the bottom of this layer cake, or this stack, if you will. Somebody grabs Unity, and they grab Vuforia, or ARKit, or ARCore, and they build an app, and they demo it. And everybody says, oh, wow, that's amazing. It is amazing, but it doesn't scale very well. Because in the enterprise world, there are so many use cases and so much variability. I mean, you'll run out of software engineers long before you get all those use cases implemented. And you'll run out of money to pay those software engineers, too. So this is a great technique, maybe for a product catalog, where you want it to be very carefully crafted and you know, a branded, very careful experience, like the Walmart example we saw earlier. I'm not sure it scales to mainstream internal use cases with service technicians and manufacturing workers and so forth. The next level up would be to publish content using sort of a 3D web technique. So that Howden example with the new HoloLens was an example of publishing technique. Up from that would be capture and replay expertise. So the retiring worker scenario, where the Joe retired and was replaced by Alexa, was an example there. And then the top example, or top layer, would be just ad hoc collaborative AR, which was the use case with the young woman in the control room. So if you think about the startup costs and the amount of people who can contribute content, is radically different across those. But again, there's no right and wrong answers. They each have strengths and weaknesses, and it's like having a toolbox full of tools. You know, it's hard to pound nails with a screwdriver, and it's hard to turn screws with a hammer. You really need both of them. Just got to use them in the right circumstances. How about content? Where will the content come from? Well, in the Howden example, data, text, and IoT data coming together in a visual experience. 3D holograms, you know, in a lot of the furniture and product catalog examples. The example of the remote support was really human intelligence in the moment being injected into the AR experience. We can also use artificial intelligence and you know, bring data from whatever set of IT and OT systems that we need in order to make that experience highly relevant. So the second question is, where would you get this content from? Now, a lot of examples, and particularly product catalogs, are purpose-built. When I watched the example from House, you saw all those people sitting around modeling things in 3D. They're creating very special purpose models, which again, that's okay if you have to do it that way. It'd be a lot better if you could repurpose models that already existed. Every couch already had a model because the factory needed it. So I'm not sure it makes that much sense to remodel it again later, but if you have to, okay. It would be better in many enterprises if you could repurpose data you already have and blend that together with IT data and OT data, maybe with simulations and AI and ML capabilities and you know, human contributions. And then finally, how will you configuration manage it? And it turns out in an enterprise setting, this is incredibly important. So the first thing would be hard-code it. Build an app that all the content for the app is inside the app. You download the app from the App Store, it's the code and the content all in one package, great. But every time you want to change anything, you want to change the content, you have to change the code, which is a problem. So maybe a better strategy would be have the app read files off some file system somewhere. And therefore, you could change the files, and the app would just read the new versions of the files. You could take that to the next level and say, we really need to think about this like the web, where there's a database of content, and we dynamically extract versions and configurations of data in order to create an experience on the fly. Sort of like your web page for checking your stocks. You know, each one of us has a different portfolio, and the price of stocks change every minute while the stock market's open. So we need to figure out what's your portfolio of stocks, and then what are the current value of all those stocks, and then generate a page and show it to you. And then finally, there are systems, particularly in the industrial world, for managing the configurations of products, that's PLM, and buildings, that's BIM systems. And so these systems actually understand recipes. It turns out, for example, that when you're 3D modeling a product, 3D modeling systems don't actually store finished configurations. They build everything on the fly from a recipe. Why is that? Because there are millions of possible configurations. It's a bit like a software build where you're pulling in the source files and the header files, and you're pulling in shared libraries, and you're building an executable. That's the way 3D works for objects in particular that are configurable. And it turns out that if you're going to have an experience that explains how to use or repair a product, well, that experience has to be as configurable as the product is. because you can't possibly create an instance for every product configuration. I have a German customer I was talking to last week, and they make heavy equipment. I said, how many configurations do those machines come in? And I'm not joking. They said trillions of hypothetical possible configurations. Very few of them ever get built, but trust me, you're going to have to build the AR experiences on the fly in order to match up against them. So that's this concept of configuration management and digital thread. Digital thread means if you change something here, that change will flow down following the thread, and a change to a design would affect the manufacturing instructions, it would affect the service instructions, it might even affect the operating instructions, because that change will flow down across all of those downstream derivatives. So configuration management, it turns out, is going to be a very key thing. And I've argued here that AR needs PLM as bad as CAD ever did, 3D modeling ever did, for exactly the same reason, too much variability. Okay, so now we're ready to deliver this thing. So the first thing is, how do you fire it up? It may be a custom app, kind of hard-coded, it does what it does, you launch it and it does that. It could be more like a web browser or a general purpose app where you pick a menu, or maybe you scan a code or a marker, or perhaps you approach some near-field wireless signal and that launches it, or maybe even you're doing sensor fusion, which is, there's a machine here, I recognize the shape of the machine, and I know at this GPS coordinate there is only one such machine, so I know which one it is, I can launch the unique instance accordingly. Let's keep going. Then mapping and localization. Mapping refers to how do you place the AR content in spaces or on things. And again, you can use waypoints, which are GPS or spatial anyway. There's different forms of waypoints, if you will. You could use markers and say, I see a marker and that's all I care about because that's my 0, 0, 0 point. And I'll just place content relative to that marker and ignore the room and the things in it. I could say, I'm looking for a surface. So I want to find a surface and put content on it, touch a spot on the surface, and that's where the content will attach. I could use beacons and so forth. And then the second question, if I know where the content is, where am I? Which room am I in? Which thing am I standing in front of? So that you can line me up with it and understand the spatial distance and angle and so forth between us so that all the information can be represented accordingly. And again, we could say just manually align everything, or use a GPS or some form of spatial waypoint. We could, again, use beacons and images. We could do object recognition. The example with the new HoloLens from Howden was object recognition. It saw the system it was looking for, and there was that yellow flash that went across the system to tell the user, I see it, and then it used that whole system as its coordinate system. And of course, terrain recognition would mean I'm in a space and I'm looking around, and based on these 3 metal poles and screens at different locations, I think I know where I am because I'm recognizing part of the terrain as if it were an object. And then we could do sensor fusion and different forms of AI as well. And then finally, okay, it's time to fire this thing up. Are we going to use cached content? Sometimes that's important, particularly for workers who go into places where they lose connectivity. They don't have Wi-Fi or 4G, 5G. They need content to bring with them. You could download the content in the moment. And then a lot of the use cases, like when Alexa was the new employee, we had to stream that data because those procedures can go on for hours and hours and hours. And so we want to stream whatever portion is useful to her right now. Otherwise, we're going to be dealing with the problem that the device maybe just can't handle it all. And then how do we get feedback from the end user? Well, we could have an app that doesn't allow feedback. That's not uncommon. You could touch the screen of your phone. You could speak. You could gesture, like with the HoloLens and other devices. You could have a virtual HMI, like that Howden example did. You could track somebody's eyeball. What are they looking at? Because if they look at a certain subsystem, I should fire up the experience for that subsystem. You could use location. Like Jim just walked up to a certain machine in the factory, I should tell him about that machine. Or you could use IoT sensors. It could be something the user's wearing or other sensors in the environment. For example, a camera that sees a user has approached some spot where there should be AR content presented to them. Okay, let's go ahead and trigger it. All right, so that was a lot of stuff, but I hope you can see that each and every one of those use cases. In fact, to make sure you see, I'm going to tick through kind of how I thought about them. So product holograms. I want this to be augmented. It's just going to be visualization, not much interaction. It's just going to be sight, vision-based. I don't need sound. It has to run on phones and tablets. But it has to run on any flavor of phones and tablets, but only one at a time because it's a single user experience, so far as I know. If it required, HoloLens or something like that, you even saw one of those videos say it doesn't require any fancy glasses, which is very important in a consumer-facing use case. Then if we get down to the 3D reference model, how do you know where to put the content? You see a plane, you touch the plane, we just put it there. It's no specific reference point. In fact, you move it around and resize it and so forth. How was that IKEA experience authored? That was coded. That is a 3D app, a special custom app you download from the App Store to get the IKEA 3D product catalog. What kind of data did we use? Text and 3D holograms. Where the information come from? It was all purpose-built content. Again, like the example from House where they're sitting around building purpose-built content. Mixed with IT data, because the description of the thing, the price, that might be dynamic data being pulled out of databases and fed into that experience in real time. Be a good idea. Otherwise, your product catalog will quickly get stale. The prices will be wrong, and the products will be wrong, and so forth. And that's why we should be pulling that from a content server, so that each time you use that catalog, it could be different, because the data is coming from outside in a carefully managed way. Okay, it's a hard-coded app. It only does that product catalog. We detect the surface with computer vision. We bring the information onto that surface by touching the surface at a point of reference that becomes the 000 point, in effect. And we download the content and allow you to interact with it on the touchscreen of your phone. So that was one scenario. Here's a different scenario, the manufacturing work instructions. This is augmented, but now it's instruction and sense, because I want to know that the person did every one of those steps. I don't just want to tell them what to do. I sort of want to confirm they actually went through all that stuff for quality control purposes. This is probably sight. It needs to be a head-mounted device, because workers need their hands. They can't generally hold a phone or a tablet because they need to hold a part and a wrench, or two hands on a part or something like that. So this one really needs to be head-mounted, maybe just on Windows. But if we got to the point where there were more viable HMDs out there, I hope that day is coming soon, I probably need this to be cross-platform, multi-platform. How will I present the data? Well, I had a 3D object model of the actual battery being assembled, and that was my coordinate system for putting the instructions out there. This information was authored. In fact, it was repurposed content, so we used the engineering design as the basis for the AR manufacturing experience, and we pulled this information together, 3D holograms and text and images. And this data came from a PLM system, because again, if there's a slight design change in the battery, I need the instructions for assembling the battery to immediately, at the right moment anyway, incorporate that design change into the battery assembly instructions. Otherwise, I'll be explaining how to assemble the old battery while telling somebody to assemble the new one, and that won't make any sense. I picked this one from a menu. I used the battery's frame as the coordinate system. I recognized the battery frame, and that's how I linked to that coordinate system. I then downloaded the content and allowed the user to do gestures and also touch buttons like next as a way to go forward and back and so forth. Okay, I'll keep going because I don't want to hit these in super detail. That's not the point. But again, knowledge transfer, I wanted spatial capture. So again, I decided this one really needs to be on a HoloLens. I'm going to show you in a minute. I'll allow the replay to happen with or without spatial, because at replay time, you can just ignore the spatial anchors. But I sure would like to have them in the experience that Joe's going to leave behind, so that, as more and more smart glasses become available, we can show you where Joe walked and where Joe stood while doing the next step and what he was looking at and so forth. Here, though, I captured the content. I didn't author it as a technical publisher, and I didn't code it as a coder. Joe authored it. Joe authored it by actually doing his work, and I captured the work as he did it. Stored this on a content server, maybe a PLM server. Joe launched this with a menu pick. You might have seen that. The 3D waypoints were the way we anchored content, spatial anchors. We localized using, it says GPS here, but I think probably actually it's terrain recognition. It's probably an error in my use case here. We streamed the data from Joe and ultimately back to the new user. Now, if we switch to the new user, it's a different story, because I said I'd like this to be able to be replayed on HoloLenses or phones and tablets or assisted reality devices. And on the assisted reality device, we'll use all the video and instructional content. We'll just ignore the spatial anchors because we don't know how to represent them. So that gives me a very different story now, and lots of different hardware that could be used, which means lots of different operating systems that need to be supported. I can either not have a 3D reference model, or I can use the spatial model that the HoloLens captured. If I come down to authoring, I mentioned that this was captured already as images, sound, and video. It is purpose-built content because it's one stream of data, and I can chop it up and edit it and so forth, but it was created to explain this one process in this one setting. Maybe I can copy-paste and put that same process in lots of different settings. That's an interesting concept, and we call that retetherable down in the lower part. So anyway, that's just a little bit more on that. Warehouse logistics, again, a different combination of things. Lots of use of IT systems and OT systems. We don't want to author where that forklift ought to drive. We want to generate that by understanding where is the forklift, where is the product he's supposed to pick next. Let's generate the instructions to get from here to there and deliver them into that particular system. Okay, and then the customer self-service. So this one, again, has to run on phones and tablets because I cannot assume that a blood and urine testing lab is going to have anything other than phones and tablets. But I don't know what type of phones and tablets, so I'm going to have some type of environment that supports them all. So again, it'll be AR, phones and tablets, cross-platform. It will use the object model of the actual diagnostics machine as the reference point and the coordinate system. We will author technical content for that. We'll pull in, repurpose information, 3D holograms and text and images from databases like CAD and PLM. We'll combine it with IoT data and maybe as well AI, because it might be that by looking at the sensor readings coming off that machine and applying AI to them, we can do, for example, predictive analytics to see that there's going to be a problem and to coach the user through the fixing or the avoidance of that problem. Again, I'm going to need to configuration manage this content. This particular case was launched by scanning a marker on the machine, and then we switched to the recognition of the object and placed all the content and measured the location of the user relative to that machine, downloaded the content, and allowed the user to give us feedback on a mobile touchscreen. Remote support, just worth pointing out a couple of differences here. This one, again, is ad hoc. Nobody authored anything before this scenario started. It all happened in the moment. Again, has to work on phones because I can't assume that anybody on either end would have anything else except in very special situations. Again, it'll be spatial. It'll be streaming content because it's really a video call underlying it, and we're going to run it on mobile phones. And then finally, this virtual HMI, it's augmented. It's using different techniques that allow you to interact with the machine. And also that machine is sensing where you are. I mean, not only do I know where the machine is and what it's doing, but that experience, we know where the user is and what the user's doing. We're tracking both of them again, AR being IoT for people. That ran on HMD, on Windows. Again, happened to be object model based. We brought in a lot of sensor data into that one, of course, IoT data and sensor fusion and streamed information down. We also, on the last line, how do we get feedback? Well, the user can speak, they can gesture. We gave them a virtual HMI to interact with to give us feedback, but we also know where they are because this is a spatial use case. And again, as they approach something, I know I should tell them about that thing if there's a reason to. And I shouldn't tell them about something that's far away because it wouldn't be relevant. A little bit like Google Earth giving you more detail as you get closer and closer. Okay, so I want to do a quick review, if I could have you jump back here. And all I want to do is show you the green patterns here. I'm not going to talk about them, but just to show you, here's one pattern, here's a different pattern, here's a different pattern, again, a different pattern, another pattern. Because the takeaway, as we go through all these different patterns, is that there are a lot of patterns. You need a lot of technology to do enterprise AR. It's not really that simple because each use case has so many tough questions. And again, my goal here is just to have a framework so that you can discuss one use case versus another and understand the choices you have to make and why you would make one choice versus another, and to realize that they're not exactly the same. So here's my closing thoughts then. First, enterprises have much to gain from AR. Worker productivity and quality. They can differentiate their products and say my product's better than yours because of the digital experience wrapped around it. They can transfer knowledge from one worker to another. They can change the customer support model. I mean, there's immense amount of value that could be created. So there are actually many relatively obvious and very high value use cases, but they require a wide range of technology. So I think, and what I'm starting to see is that enterprises are saying, you know what? We're going to need an enterprise platform for AR. Because if we go out and source different point solutions for each and every use case, we'll be swimming in point solutions that don't work together, we can't reuse content, so on and so forth. We're going to need a consistent way, just like we have one ERP system, we're going to need to have one way to do AR, and of course, that's really how we're positioning our Vuforia suite. So if you want these slides, you can email me at jim@ptc.com, and I'll be happy to share them with you. Thank you very much. Bye-bye.